Okay, now we're on part C, the third video for the unit circle. Now we're going to talk about the 30, 60, 90 on the unit circle. So let's just go back for a moment. If I'm talking about the special 30, 60, 90 triangle, here it is. Again, if I count counterclockwise, I'll label numbers clockwise. Here's 30, here's 60, here's 90, here's 1, 2, rad 3. Opposite the 30 is in a 1-to-2 ratio with the hypotenuse. Always make sure it's labeled right. So now let's tie this into the unit circle. So again, before I draw the unit circle, let's just label the sine of 30 is 1/2. The cosine of 30 is rad 3/2. And the tangent of 30 is 1/rad 3, which cleans up to rad 3/3. Then we have the sine of 60, which is rad 3/2. We have the cosine of 60, which is 1/2. And then we have the tangent of 60, which is rad 3/1 or rad 3. So the reason why I went back to that is because we're going to see the decimal version of this in a moment. And we're going to go back to the unit circle. So here's my unit circle, which again, here's x positive, here's y positive, x which is negative, y which is negative. And if I draw my circle, which I didn't draw the circle the other before, I just drew the radius, which again, here's the radius. Now, the important thing is the right triangle that we drop. Let's say that I put in a 30-degree angle in quadrant 1. Well, this 30-degree angle in quadrant 1, again, had to come out a value on the x. I had to go up to a value on the y. So that's the y coordinate. That would have been the x coordinate. And then I get my point P on the unit circle. Now, again, this is the length I came out on the x-axis. This is equal to my cosine of 30 degrees. The height that I went up to on the y-axis would be equal to my sine of 30 degrees. So my ordered pair is my x-coordinate, my y-coordinate, but it is also, very important, it is also the cosine, comma, the sine. So 30 degrees. Now, if I am talking about a 30-degree angle, the sine of 30 degrees is always going to be opposite to the hypotenuse. Excuse me, I drew my arrow wrong. Opposite to the hypotenuse. Now, if I have a radius of 1, they would have to give me my other values here, which my other values come from the sine and the cosine. So if I want to know the coordinate for the cosine for, say, the x first, I would say, okay, cosine of 30 degrees. Now I know it from my special triangle. The cosine of 30 degrees is rad 3/2. And I know the y-coordinate is going to come from the sine of 30, and the sine of 30 from my special triangle is 1/2. These are exact values. Now, if I wanted the decimal value, because say I'm on a graph and it's, I can't really figure out where rad 3 is on a graph, I can figure out 1/2, but rad 3 might be difficult. If I, again, make sure I'm in degree mode and I put the cosine of 30 degrees in, I get 0.8660254,038, and I'm going to round that to 0.87. And this will be 0.5. Now, if I were to take rad 3 over 2, just to show you, if I now take the rad of 3 and I divide that by 2, I get the exact same thing. These two guys are the same, and that's so important. So this would be quadrant 1. This would be a 30-degree angle in quadrant 1. So quadrant 1. Now let's do what we did with the other example. I'll use a different color for each quadrant. Now I want a 30-degree angle. Whoops, I can't use blue. I said I want to use different colors, so that was silly. Let's fix that. I want to go a 30-degree reference angle in quadrant 2. Well, in quadrant 2, here's my 30 degrees. Here's my right triangle referencing the x-axis. That means this would have had to have been a 150-degree angle. So now if I'm in quadrant 2, I have the sine of 150 degrees is equal to positive sine of 30, because sine's positive, y-coordinate, sine's positive in quadrant 2, and the sine of 30 is 1/2. The cosine of 150 degrees would be negative cosine of 30, because in quadrant 2 my x is negative, so my x-coordinate is negative. My x-coordinate is my cosine, and so the cosine of 30 degrees, this would be negative 0.87. So this point here would be negative 0.87, 0.5, positive 0.5, if I were to write the coordinates, where this one would have been positive for both. This would have been the point, positive 87, positive 0.5. If I wanted to go into quadrant 3, so quadrant 3, if I want a 30-degree reference angle in quadrant 3, I went, this is a 210-degree angle. 210 degrees is 30 degrees beyond my 180. So this is my 30 degrees in quadrant 3. Now quadrant 3, x, my cosine, and y, my sine, are both negative. So this would be the sine of 210 is equal to negative sine of 30, negative 1/2, and this would be cosine of 210 would be negative cosine of 30, negative 0.87. So this point here would have been negative 0.87, negative 0.5. And lastly, quadrant 4, if I want a 30-degree reference angle in quadrant 4, what color have I not used yet? Orange. All right, so now quadrant 4 is my orange. Let's see if I can fit it here. No, that's not too dark. Let's see if this other orange one is darker. All right, so now I would need a 30-degree reference angle, which means I had to go 330 degrees to get to a 30-degree reference angle in quadrant 4. So if I had the sine of 330, this would equal negative sine of 30, because sine is negative in quadrant 4, so negative 0.5. And then I would have the cosine of 330. Cosine's positive in quadrant 4, so this would equal the cosine of 30, and that would be 0.87. So this point here would be 0.87 positive, negative 0.5. So it still follows all students take calculus. You are positive and negative based upon the quadrant you fall into. If you are on the unit circle, the x-coordinate is the same as the cosine of that angle, and your y-coordinate is the same as the sine of that angle. So far we only talked about sine and cosine, but I think that's enough for today with this part of the unit circle. So now that you've watched these videos and you've taken notes, give your mind a little bit of a chance to relax. And then I am going to ask you to please try to do the packet from eMath instruction on the unit circle. So give it your best shot, and I will put up the answers tomorrow.